Working through some more Core Pure now, we're going to take a look at complex numbers. Now this is only involving the Core Pure 1 book 1 here, because I'm kind of basing this video as more of an introduction to complex numbers. So there's going to be nothing like Dumoir's theorem, looking at roots of unity, nothing like that, just the basics in this video. Okay, so I'm going to do another video on the more advanced stuff with complex numbers, which I'll be using book 2. But like I said, primarily for this video, book 1 and some previous exam paper questions. Okay, so let's take a look at what we've got. So the first question is a really nice, easy introduction here. So we're working through the Core Pure 1 textbook, exercise 1A, question 6. So what we've got here, we've got two complex numbers. We've got Z1 and Z2. And what it says is that Z2 minus Z1 is equal to 7 plus 2i. And we have to find A and B. And A and B are both real numbers. So 2 marks for this. So there shouldn't be anything too advanced with it. So let's look at what we've got. So Z1 is A plus 9i. So we don't know the real part of that complex number there. And Z2 is minus 3 plus bi. So we don't know the imaginary part for that complex number there, Z2. So what we do know though is that Z2 minus Z1 is equal to 7 plus 2i. Well, Z2 is minus 3 plus bi, so if we do Z2 minus Z1, we can then equate the real part to that part there and the imaginary part to that part there. So let's do that. So that's the same as doing minus 3 plus bi minus a plus 9i. Okay, that's Z2 minus Z1. Now what that's saying is minus 3 minus a, so minus 3 minus a, so that's this bit here, so minus 3 minus the a, so them are the two real parts, so that should be equal to this real part here. So minus 3 minus a should be equal to 7. And then let's do the same for the imaginary part. B minus 9 should be equal to 2. So B minus 9 should be equal to 2. Okay, so now we just need to solve these. So this one's dead easy. B minus 9 is equal to 2, so therefore B is equal to 11. And the a part here, well, I can add 3 to both sides, so minus a is equal to 10. So therefore a must be equal to minus 10. Okay, so there we have it. So that's a, which is minus 10, and b is 11. Okay, so a nice easy question there just to get us started, just equating the real parts together and then the imaginary parts. Okay, so hopefully that's nice and easy. Let's have a look at what we've got next. So this is from exercise 1B, question 6. So we've got an equation, z squared plus bz plus 11 is equal to 0. And b is a real number. And what it tells us is that this has distinct non-real complex roots. And it wants us to find the range of possible values of b. So this bit here, the fact where it mentions about there being non-real complex roots, is the important part of this question. Because remember, from your studies of A-level maths, we're looking at the discriminant now. So if it's distinct non-real complex roots, what that means is b squared minus 4ac is less than 0. Okay, so we can use that information now with the quadratic that we've got, z squared plus bz plus 11, to use a discriminant. Okay, so what that'll be is, because it's bz, it'll be b squared minus 4 times a, which is 1, times c, which is 11. Okay, and that has to be less than 0. So let's keep going with this. This will be b squared minus 4 times 1 is 4, times 11 is 5, 4 is less than 0. Okay, now this would be the same as saying b squared is less than 5, 4. But first let's think about this quadratic here. Imagine you were to sketch this out now. Okay, this is a quadratic which is going to cut through the y-axis at minus 5, 4. Okay, so minus 5, 4. So let's just say for simplicity it's there, minus 5, 4. But it's going to cut through at 2 points which we don't know quite yet. So let's just say that it's point A and point B for now. Okay, so it's going to cut through obviously Should look a little bit neater than what I've got there. But that's my quadratic. Now if it's less than 0, we're looking for these values here. This range of values here. Okay, so knowing that now, all we need to find is what A is and what B is, so where it's cutting through. And once we've got that, then we just set it up as an inequality like this. Sorry. Yeah, so it can be B, sorry. So that should have been C, really. Don't work with B. So B is between A and C, for example, like that. Okay, so this would just be the same now as taking the square root here. If I take the square root, that'd be the square root of 44, but I could also have the square root of minus 44. So this would be minus root 44 and root 44. But remember, root 44 we can simplify, so root 44 is equal to root 4 root 11, and root 4 we can simplify as being 2, so this is 2 root 11. Okay, so B now, we can write this range as being minus 2 root 11 and 2 root 11. Okay, and that's my final answer there for the 3 marks. So you can give your answer as just this if you really want. Well, that's a nicer way of giving it though, with the minus 2 root 11 and 2 root 11. Okay, so there we have it. So that's that question there. Let's move on to the next one. So this might be quite a quick video because, as you can see, the questions are pretty short. You know, so in the Core Pure 1 textbook, they're quite nice questions. So we've got two complex numbers here, Z1 and Z2. Z1 is P minus 7i, so let's write that down. And Z2 is 2 plus 5i. So what it wants us to find is Z1 over Z2 in the form A plus BI. So Z1 over Z2, that's the same as P minus 7i over 2 plus 5i. Okay, but remember, when we've got it as a quotient like this, we have to multiply through by the complex conjugate. So we're going to times both top and bottom by 2 minus 5i. Okay, so it's important that you multiply by the conjugate. Okay, so let's have a go at expanding here now. So P times 2, so that'd be 2P. P times minus 5i, so that'll be minus 10pi. So first outside inside, so that'd be minus 7i times 2, so that'd be minus 14i. And then finally minus 7i times minus 5i, so that'll give you positive 35i squared. Okay, so let me just double check I haven't made any mistakes. Minus 5i. Sorry, so yes, so that should be, so that'll be 2p, that'll be minus 5ip, or pi. I'm not sure where the 10 came from there, so minus 5pi. Okay, this will be over now. 2 times 2, which is 4, and remember, because this is the difference of two squares now, I can just do 2 times 2, so that's 4, and then do 5i times minus 5i to give me minus 25i squared. Okay, so now what I need to do is simplify both my numerator and my denominator. So can we do anything here? So we've got 35i squared. Well, remember, I squared is minus 1. So 35 lots of minus 1 there. So that'd be 2p minus 35 minus 5pi minus 40i. Okay. And then finally, the denominator is going to be 4 minus 25 times minus 1, so that'll be 4 plus 25. Give me a denominator of 29. Okay. So simplifying this now. In fact, I don't need to simplify because I can't simplify any further. All I'm looking to do now is write it in this form here. A plus bi. So what I need to do is split the real parts up and then split the imaginary parts up. Well, my real parts I've already actually branched together here. The 2p minus the 35. We know they're the real parts. There's no imaginary parts. Anything that's got an I next to it is part of the imaginaries. So I could write this now as 2p minus 35 over 29 plus minus 5p minus 14 over 29. Now there should be an I next to that, so if I just write it underneath just so I can show my answer fully, 2p minus 35 over 29 plus minus 5p minus 14 over 29 I. Okay, so we've got it in the form a plus bi. That's my a, that's my b, and we've given it in terms of p as well, so everything's perfect, and that gets you 4 marks for that question. Moving on now to this one here, question 3 from exercise 1e. We're given a root of a quadratic equation with real coefficients, so we've got 2 plus 3i being one of the roots. Now part A is just a 1 marker, and it says write in the other root of the equation. So for 1 mark, you should be thinking now, there's not going to be much to this. If anything, it should be really obvious. And the reason it's only 1 mark is because you have to remember that complex roots occur in conjugate pairs. Okay, so if one of my roots is 2 plus 3i, my other root is just simply 2 minus 3i. Okay, so that's my other root there, 2 minus 3i. Okay, so nice easy there, starter. Let's move on to B though. So B wants us to find the quadratic equation, giving your answer in the form z squared plus bz plus c is equal to 0. So remember, we've got the 2 roots here. So we've got the 2 roots. So if we've got the 2 roots, we can actually just go on to work out the quadratic now. So remember, if this is one of the roots, just like for example, if we had one of the roots being 3, that would be the same as doing z minus 3 is equal to 0, for example. Okay. So we've got to do the same with these roots now. So my first bracket will be z minus 2 plus 3i, like so. And then my other root will be z minus 2 minus 3i. Okay. And we just need to expand this now. So z times z gives me z squared. We need to do z times minus 2 minus 3i. So z times minus 2, so that'll be minus 2z. Z times minus 3i, so that's plus 3i. So that'll give me plus 3iz. We then need to do minus 2 times z, so that's minus 2z. And then minus 3i times z, so that's minus 3iz. And then finally we need to do minus 2 plus 3i times minus bracket 2 minus 3i. Okay, so we've got to do, basically we're doing this, minus 2 plus 3i times, if I multiply that out, minus 2 plus 3i. Okay, so multiplying this out now, let's just expand this bit here with the minus, so that'll be minus 2 plus, screw all that, minus 2 minus 3i minus 2 plus 3i. Okay, so we just expand this now. Minus 2 times minus 2 is 4. So I'm going to get a plus 4. So plus 4. I'm going to get minus 2 times 3i, so that'd be minus 6i. I'm going to get minus 3i times minus 2, so that'd be plus 6i. So they'll just cancel anyway, and then minus 3i times 3i, that'll be minus 9i squared. Okay, so minus 6i plus 6i minus 9i squared. Okay, so this is everything we need now. We can't expand anything else in this expression here, so we can't expand anything else there. So all we've got to do now is simplify. We've got our quadratic. So what you'll get often with these questions, you'll get a lot of things that you can just cancel. And if you notice, I've got a positive 3iz and a minus 3iz. So they cancel straight away. We've also got a minus 6i and a plus 6i. So now we can just simplify this. I've got z squared. I've got minus 2z minus another 2z. So that's minus 4z in total. And there's no other z's. So that's everything. We've got plus 4 minus 9i squared. So remember, I squared is equal to minus 1. So if you've got minus 9 lots of minus 1, so minus 9i squared is equal to minus 9. times minus 1, okay, which will just give you positive 9. So then we've got 4 plus 9 giving me plus 13, okay, and that's equal to 0. So that's my quadratic. So what that means is that B will be my minus 4 here, and then my C will be 13, okay. So that's all you've got to do for that. You just got to be very careful when you expand there, especially with the last two terms, that term there and that term there. What I'd always do for one of them is write it out like that, and then just expand to get your few terms that you need, okay. But that's everything that you need for that one. Let's move on to the next one. So this is from the mixed exercise now, question 10. So we've got z is equal to a plus bi, so just a standard form of a complex number. It wants us to show that z divided by the complex conjugate, so this z star, remember z star is the complex conjugate. Okay. So we've got the complex conjugate. We just, obviously that would be just a minus bi. So a minus bi. So we need to show that it's equal to this expression here. 4 marks for this. Well, let's write how it is. So this is a plus bi. So this is z over z star. So that's a plus bi over a minus bi. Okay. But remember, when we've got complex numbers as a quotient like this, when we define them, we have to multiply through by the complex conjugate again. So now we just times it through by a plus bi. Do the same to the denominator, a plus bi. So now, all I need to do is expand my brackets here and then simplify, and we should, everything going well, get this expression here. So straight away, a times a, that'll give me a squared. A times bi, so that'll give me a bi. Bi times a, so that'll give me another a bi. And then finally, bi times bi, that'll give me plus b squared I squared. Okay. So that's my numerator. Let's expand for the denominator. So a times a will be a squared. And remember, because this is a difference of two squares now here, a minus bi, a plus bi, I can just multiply the first term, so a, and then the last term, so minus bi times positive bi. So that will be minus b squared I squared. Okay. So again, using the fact that I squared is equal to minus 1 to help with this. Well, I've got a squared, I've got abi plus another abi, so in total I've got 2 abi. And we've got this b squared times I squared, but I squared is minus 1, so this b squared is times by minus 1, so we can write that as minus b squared. Okay, so that's my numerator fully simplified. My denominator, I've got a squared minus b squared times I squared, but I squared is minus 1, so this is minus b squared times minus 1, so we can actually just write that as a squared plus b squared. Okay, so now all I've got to do is just get my real parts together and then get my imaginary parts together. Well, my real parts is just the a squared and the b squared, so anything that doesn't have an I next to it, so that would be a squared minus b squared, and now this would be over the same denominator, so it would be over a squared plus b squared. And then we can do the same with the imaginary part. I've got 2abi, so we write that as 2ab over the same denominator, a squared plus b squared, and we write that as the imaginary part there. Okay, and that's simply all we've got to do for that one. So 4 marks for that. As you can see, these questions are really nice. Again, like I said, it's just aimed as a basic introduction to complex numbers, and just as a quick recap, I guess. So now the final 2 questions are from exam papers. So these might be what you're going to see basically on one of the AS exams if you're sitting the AS. So you've got f of x here being this cubic polynomial. We're given that x equals 3 is a solution of the equation, so we're asked to solve it completely. Well, if x equals 3 is a solution, what that means is, so x equals 3 is a solution. What that means is x minus 3 would be equal to 0. So that would be how we solve it. That would give us x equals 3. So what we can do now is write this as a product. So we know the first solution is x minus 3. Now, because it's a question on complex numbers, the next part of this must be quadratic, and because it's 2x cubed, this must be 2x squared. Okay, so we're going to get this quadratic now basically by doing inspection, because we know a few things about this. We know this here, this quadratic here, should give me a complex conjugate of roots. So for example, if say it's like 5 plus I, my other root would be 5 minus I, for example. Okay, so they have to occur as a conjugate pair. But what we do know, for example, so if I say this is 2x squared plus bx plus c is equal to 0, we know when we expand this, my x squared term should add up to minus 8. Okay, well, straight away think about expanding this. You do x times 2x squared, so I give you your 2x cubed, so that's fine. But I want to know about the x squared term. So the only time I'm going to get an x squared is by doing 2x squared times the minus 3. And also, so if I just change my pen just to illustrate it, also when I do bx here, so my bx times the x as well here at the beginning. Okay, so what we've got to think about now is what we'd get. So if I just change back to my white pen, well, if we did 2x squared times minus 3, that would give me minus 6x squared. And the only other term that can give me to get the x squared is the blue one. So we've just done the white one. So the blue one now, we need to be another minus 2x squared. So blue must be minus 2x squared to give me the minus 8x squared. Okay. So using that information now, we know b just simply has to be minus 2, because the x is just, it has a coefficient of 1, so we can't change that x. So b has to be minus 2, okay? So using that information, b is equal to minus 2, okay? And then the other term that we need is this c here, okay? So the c term here, well, to get the c term, that's really easy. All you've got to do is look at the very last term in the cubic, so that's minus 3. Well, that comes from doing this number here. So if I change my pen colour again, that'll come from doing the minus 3 times the c term here. Well, minus 3 times c, that'll give me minus 3c. Well, that has to be equal to minus 3, right? Because that's what the last term is. So therefore, c must just be equal to minus 3 divided by minus 3, which is equal to 1. Okay, so the polynomial now, the cubic polynomial, we can write that as 2x cubed minus 8x squared. Oh, sorry, no, online. I mean the quadratic here, so that would be 2x squared minus 2x there, and we've got a minus 2 at the end. Oh, sorry, plus 1. What am I on about here? So minus 2x plus 1, okay? Because that's what we worked out c to be, plus 1, okay? So what we need to do now is just solve this. So solve this, and this gives us the other two roots. And what we should get is that they occur as a complex conjugate pair, okay? So I'm going to use the quadratic formula for this. So if we just do it up here, so x is equal to minus b, so minus minus 2 is 2, plus or minus the square root of b squared, so minus 2 squared, minus 4 times a, which is 2, times c, which is 1. And this is all over 2a, where a is 2, so 2 times 2 is 4. So just keep solving this now. X is equal to 2 plus or minus, so this is going to be 4 minus 4 times 2 is 8, times that by 1, so that'll just be a again. So 4 minus 8 all over 4. Keep solving and simplifying here. So x is equal to 2 plus or minus, so the square root of 4 minus 8, that'll be the square root of minus 4 over 4. So again, simplifying here, the square root of minus 4 is the same as 2i. So that's 2i over 4. So now we can just simplify. If we divide the 2 by 4 and then the 2i by 4, we're going to get x equal to 1 plus I. Sorry, plus or minus I over 2. Okay. So them are my full solutions there. So one of my solutions is x equals 3. X equals, so if we write them all down, x equal to 3, 1 plus I over 2, and then finally 1 minus I over 2. Okay, so 5 marks for that. And as you can see, you've just got to do a bit of preliminary work here, obtaining your quadratic. And once you've got the quadratic, just solve that using the quadratic formula. Okay, so hopefully that makes sense. Hopefully this bit over here didn't confuse you. That should just be a +1 at the end there. Okay, but if there's anything unclear, just leave a comment. We'll cover it together. And then finally, let's move on to the very last question. I picked a nice easy one. This is the Jan 2016. This is the IAL. So this is the Edexcel old exam questions from FP1. And this is a nice one to end with. So question 1A is just Z times W. So sounds silly, but when you've just got the two letters again together here, it just means multiply together. So Z times W, so that's Z, which is 3 plus 2i, times W, which is 1 minus I. Okay, 3 times 1 is 3. 3 times minus I gives me minus 3i, plus 2i times 1, so that gives me 2i, and then 2i times minus I would be minus 2i squared. Well, what do I get when I simplify this? So this is going to be 3 minus 2 lots of minus 1, so that's plus 2, so that's going to be 5, and then minus 3i plus 2i will just give me minus I there. Okay, so ZW is equal to 5 minus I. And then finally, Z over W conjugate. So remember the W star is just the conjugate of W. So B. So that's going to be 3 plus 2i over 1 plus I, like that. Okay, because W is 1 minus I, so W star must be 1 plus I. So all I've got to do now is times it back through by the conjugate, which is 1 minus I. Now when you're doing these questions, always look carefully at whether you've already done some of the working to help you with this. I've already done 3 plus 2i times 1 minus I. That's just simply ZW here, which is 5 minus I. So I know my numerator straight away. It's just going to be 5 minus I. My denominator is just a difference of two squares. So again, that's really easy. 1 times 1 is 1. I times minus I would be minus I squared. So if we simplify here, this is the same as doing 5 minus I over 1 plus 1, because minus I squared. Well, I squared is minus 1, so minus 1 is just 1. So 1 plus 1 is 2. And then simply we can just write this as 5 over 2 minus a half I there. Okay. So 5 marks for that question in total. I don't think they're going to be quite that generous anymore with the A level. But yeah, just a nice question to end with. So I hope that's helped. Just a brief video on Corpio 1 complex numbers. Be sure to subscribe. I want to go through more further maths content. Leave a like, any feedback. Yeah, there we go.